Today's lesson is more verifying trigonometry identities. My learning target is I will verify trigonometric identities using algebraic methods. Today I'm going to use some of the Pythagorean identities. So from memory, we should have some of these, or at least the first one, and then know how to derive the other two. So I know I have sine squared of x plus cosine squared of x equals 1. This is the primary one, so that's the equation of the circle. Or I could think about it as the Pythagorean theorem. And then I'm going to divide each term by sine squared and by cosine squared to get my other two identities. And those are 1 plus cotangent squared x equals cosecant squared x, and 1 plus tangent squared x equals secant squared of x. Okay, so the process is I am verifying. So I want my left-hand side to equal my right-hand side. I choose the more complicated side and simplify so that it equals the other side. So I only work on one side. I cannot move anything back and forth, and I just have a couple strategies that I'm using. So in this case, my right-hand side is my more complicated side. So I'm leaving the left-hand side as it is. So this is the cosine of x minus 1 over sine of x. And I'm going to rewrite cotangent in terms of sine and cosine, and cosecant in terms of sine and cosine. So this is going to be cosine of x divided by sine of x minus 1 over sine of x. Again, I leave the left-hand side as it is. So this is cosine of x minus 1 over sine of x. So since I have a common denominator, I'm subtracting my numerators, and I get cosine of x minus 1 over sine of x. And I am done. After I've showed my left-hand side equals my right-hand side, we place a check mark to show that I have verified. Okay, let's try another one. This one I'm going to use a difference of squares. So I'm going to recognize a squared minus b squared factors into a plus b and a minus b. So I am going to work with the left-hand side. And if I'm not sure which side is the more complicated side, I just start on one side and I try and simplify to the other side. If it doesn't work, then I switch to the other side. Okay, so I'm looking at, I see a minus b and a plus b in the denominator. So I see the factored form. So if I multiply by the conjugate, I know that I will go from this form into the a squared minus b squared form. Okay, so I'm going to start by, this is 1 over 1 minus secant of x plus 1 over 1 plus secant of x. And I'm not going to do anything to the right-hand side. So I'm going to leave the right-hand side as minus 2 cotangent squared of x. Okay, so I am trying to get to a squared minus b squared. So I'm going to multiply by the conjugate in the form of 1. So I have 1 minus, or a minus b. So what I see looking at this is a minus b and a plus b. So I want to multiply this one by a plus b in the form of 1. And I want to multiply this fraction times a minus b in the form of 1. Okay, so I'm going to multiply this by 1 plus secant of x, 1 plus secant of x, and 1 over 1 minus secant of x. Oops, this is going to be 1 minus secant of x. Okay, so I'm multiplying times 1 so I don't change my equation. So in the numerator, I have 1, oops. In the numerator, I have 1 plus secant of x plus 1 minus secant of x. And in the denominator, since I have the two factors, I know I'm going towards a minus b. So I know my two middle terms cancel. So I'm going to just write this as 1 minus secant squared of x. And I do nothing to the right-hand side, so this still is minus 2 cotangent squared x. So when I'm looking at this, now I see, there we go, come on. So I see this as a squared minus b squared. Okay, so I went from the factored form to this form, but I'm doing it with my trig words. So now I'm going to substitute. I know 1 minus secant squared. So I'm going to substitute the secant squared. We said secant squared is 1 plus tangent squared. So I'm going to substitute secant squared. So I'm going to leave what I see in the numerator is my plus secant and my minus secant, total 0. So I'm just left with is 1 plus 1, which is 2. And then 1 minus, and my secant squared is 1 plus tangent squared of x. And I leave my right side the same, so minus 2 cotangent squared of x. Now I'm going to distribute my negative 1, so I'm going to change the sign on my two terms inside the parentheses. So this is 1 minus tangent squared of x equals minus 2 cotangent squared x. Okay, so next I am going to combine like terms in the denominator. So 1 minus 1 totals 0. So I'm just left with a minus tangent squared x in the denominator. So if I bring that up to the numerator, that becomes minus cotangent. So I already have a 2 in the numerator, so this is minus 2 cotangent squared x equals minus 2 cotangent squared x. So my left-hand side equals my right-hand side, so I have verified. Okay, so I want to really look out for and recognize the difference of squares, the factored form, and the non-factored form. Okay, here's the sum of squares. So a plus b quantity squared is a plus b times a plus b. And when I multiply it out with my double distribution, I get a squared plus 2ab plus b squared. So I'm using that fact with this one. So looking at this problem number 3, the right side is my more complicated side. So I'm going to leave the left side as is. So this is 1 plus sine of x over 1 minus sine of x. And I'm recognizing that I have this form. So I'm going to just write this because I understand that. If you need to write it like this and multiply it out and combine like terms, then do that. But I'm recognizing this pattern because I've worked with this since Algebra 2. Okay, so this is going to be secant squared x, secant squared x plus 2 secant of x tangent of x plus tangent squared of x. Okay, now I'm going to rewrite tangent and secant in terms of sine and cosine. So my left-hand side stays the same. So I have 1 plus sine of x over 1 minus sine of x. And secant is 1 over cosine squared of x plus 2. And secant is 1 over cosine. So this is cosine of x. So I'm going to write it like this. These are all multiplied out. Tangent is going to be sine of x divided by cosine of x. And tangent squared is going to be 1 over sine squared of x over cosine squared of x. Okay, so now that I rewrote in terms of sine and cosine, I see that I have a common denominator of cosine squared. Oops. So now I'm just adding my numerator. So I have 1 plus sine of x over 1 minus sine of x. And in my numerator, I have 1 I'm going to rewrite this as the sine squared first. Sine squared of x plus 2 sine of x, because I'm going to write these in descending order. 2 sine of x plus 1. So I'm writing in descending order from highest degree to lowest degree. And then cosine squared, I can rewrite as 1 minus sine squared. So I'm going to substitute 1 minus sine squared of x. And I'm doing that because of what I see in the denominator here. So what I see looking here is this is the a minus b. This is the a minus b. I'm looking at that. And over here, I see a squared minus b squared. When I was up here as cosine, I don't have that, but this I can factor. And then this I see as the a squared plus 2ab plus b squared. Okay, so I see that. So I know that I have a plus b quantity squared divided by a minus b quantity squared. Okay, so I'm going to do nothing to the left-hand side. So to the right-hand side, so I have lefty 1 plus sine of x over 1 minus sine of x. So I'm going to take this multiplied form out, and I'm going to recognize that I have this case over here, but I want to factor it because I'm going to try and simplify. So I want to multiply things out. Oops, here we go. So I'm going to move from, I have into my factored form. So I have sine of x plus 1 times sine of x plus 1. And then in the bottom, I'm going to factor this out. So I have a squared minus b squared. So that's going to be sine of x plus 1 and sine of x minus 1. So I'm in the form where I'm all multiplied out. Once I'm multiplied out, then I can simplify by rearranging. Anything divided by itself is 1. So I have sine of x plus 1 divided by sine of x plus 1. So now it doesn't matter what order I am. So I'm going to just rewrite this so that it's in the same order. Uh-oh, what did I do? Oh, this is 1 minus sine. So I wrote these backwards. I'm sorry. So this should be, I messed up here. I'm sorry. So when I'm factoring here, this would be in the denominator. This would be 1 plus sine of x and 1 minus sine of x. So when I'm adding, the order doesn't matter. So this 1 plus sine of x is the same thing as sine of x plus 1. But I'm going to rewrite the numerator so that it is exactly like the left-hand side. So I am left with is 1 plus sine of x and 1 minus sine of x equals 1 plus sine of x and 1 minus sine of x. So I have verified my left-hand side equals my right-hand side. Okay, that's it.